introduction, why do we need to study renewable energy systems as an alternative to fossil fuels? So according to the International Energy Agency, that's the IEA, 1.1 billion people do not have access to electricity. And 97% of those live in sub-Saharan Africa and developing Asia. So currently at the moment in 2020, we still have 600 million Africans that live in total darkness. And when we talk about not having access to electricity, there's a difference between energy access and energy poverty. Currently, we do have lots of us are connected to the Nigerian grid, but we are experiencing energy poverty, going days without electricity. But even because we are connected to the grid, we're not included in this 600 million people. So you can imagine having 600 million people not even connected to any source of electricity. No matter, don't have any access. So you can imagine how life happens for them. So if you look at the graph over here on the right, this is showing briefly the world population without electricity access. And as you can see, Nigeria is one of the largest contributors. That's on a country level. Currently, there are over 600 million, as we can see, just about 620, and it is projected to increase further within the next 5 years. Unless we do incorporate some form of renewable energy, or we come up with a viable or sustainable option, this is going to increase further, and we're going to move more and more into an energy crisis. So the conventional solution to this is generating power from thermal and hydroelectric power stations. They are the most common, but of course we have nuclear power stations, which over here, that's not much of an option because of the sources and the difficulty in handling the radioactive components. So basically, our major options, the largest contributors are thermal and hydropower stations. However, when you talk about a thermal power station, they do generate lots of emissions, harmful gases. There's carbon dioxide, there's nitrogen oxide, there's sulfur dioxide. All of these lead to the pollution of the environment and have had harmful and devastating effects to our health. So because of this reason, you cannot situate a thermal station close to the load centers where people are. You need to put it in remote locations. Additionally, the hydropower stations, you can't bring them close to us because you need them to be close to a waterhead. So because of these two power stations, even though they are a good solution, not for the environment, of course, but they lead to large investments in power transmission equipment. So the best solution is going for distributed generation, and distributed generation simply means generating power where you need it. And in order to get the most cost-effective and environmentally friendly alternative is generating the energy from distributed sources by using renewable energy sources. And the two major advantages are the reduced greenhouse gas emissions and as well as the reduced cost, because we don't need to transmit power over long distances again. Now, according to research, biomass, which is a renewable energy source, can supply 26% of the world's energy consumption, and that's just biomass. And the global renewable energy capacity is set to increase to 1.2 terawatts, increase by 50%, that is, to 1.2 terawatts in 2024. And of this growth, this exponential growth, we're seeing 60% is coming from solar PVs, and almost half of that are rooftop solar PVs that we put on residential settings or small commercial settings. So this is a very important reason why we need to be investing our time and energy to R&D and incorporating these renewable energy sources, particularly solar, into our environment. And solar PVs are, of course, on track to meeting the sustainable development scenario, which is generating clean and affordable energy by using renewable energy sources such as solar in order to reduce the harmful effect of climate change, as well as increasing the quality of the air we breathe. That's 3 SDGs there: SDG 7, SDG 13, and SDG 3, just by using solar PV systems.